Welcome in. We have a lot to cover in this one. I just want to show everything in the MaxxECU tune that I used for this 5VZ 2001 Toyota 4Runner PiggyBack harness that I built. So we've got a lot to cover in here. We're just going to start over here on the configuration side and go down every box that I used to make this run a 5VZ Toyota V6 using a PiggyBack. And I've got some other wiring details and stuff too that I'll share with you as we go along. So I'll also tell you kind of where I got this information, because not all of it is easy to find, and hopefully this will help someone out there that's trying to do something similar. All right, so let's jump into it. So if we start in the configuration side, the engine settings for the 5VZ, it's a 6-cylinder. The engine displacement is 3,378 cc's. So I just did a quick Wikipedia, went to the 5VZ page, and you can see there's our cc's. So that's it's not actually a full 3.4 or 3.5, it's a 3.378. Anyway, it's just nice to have the best possible closest engine size that you can get in there. If you don't have to estimate, it'll just be a lot better. Cranking RPM, that means anything below 300 RPMs is considered cranking to the ECU. You can just leave that in there. And you can also find, on like Wikipedia, you can find the firing order and stuff like that for these. So I just put in the firing order, which is 1, 2, 3, 4, 5, 6. It's just basically alternating back and forth on that V6 between the two banks. And all these other settings are just default for right now in that configuration. So under the rev limit, just for now, I set it at 5,500, kind of the stock rev limit that's on the tachometer there. Just a really soft fuel rev limit in a sequential cut pattern. It gives 500 RPMs of control range, so it actually adds 500 to 5,500. So from 5,500, at 5,500 you get a soft cut with timing retard, and that's 25 degrees. So if there's 25 degrees of total ignition in the timing, ignition table, which we'll come back to, say you're up here at 25 degrees, it will remove up to 25 degrees on the rev limit. So you'll go to 0 basically to help control that. And then once it hits that, once it hits the limit with timing retard, then it will cut the fuel. Boost cut, all these others, we're just going to leave as default for right now. I'm not using any of those. I don't have anything additional set up. Let's jump into the fuel, and this is some important stuff. So on the PiggyBack, I am not using the cam sensor. The MaxxECU Mini only has one home input for a VR sensor, so we cannot use another VR sensor, which the cam sensor is on the 5VZ, without having a larger capability ECU, so one of the higher end models. But you can totally run it just fine without cam sync. You just can't do sequential fuel and ignition, which this only has sequential fuel from the factory but not ignition. So we use sequential 720 without sync, so the sync is the cam. It's referring to the cam sensor, so no sync, sequential 720. It just goes in the firing order with those each cylinder. Set it to gasoline for stoich, and we want 2 injector output per cylinder and 1 injector per cylinder, or sorry, 2 injectors per output, 1 injector per cylinder. And basically I just wired these the same as, so if you go to like 5VZ, FE, if you go to 5VZ FE coil pack diagram, I just wired the injectors the same as this, because from factory the injectors are all per cylinder, they're sequential, but I paired them for the MaxxECU Mini with 3 outputs. So 1 and 4, 3 and 6, and 5 and 2 are paired. We'll come back to this in a minute here, but anyway, let's move on. Injector flow settings. I found the injector flow settings. There's a company that's really well known for Toyota injectors like this. that sells the reconditioned and new injectors for these Tacomas and 4Runners. And I just grabbed its part number, found an injector flow rate table, so cc's per minute and the rating of the fuel pressure. So just found that. So they're 246 cc's and at 2.25 bar. So that's where I got that information. Just plugged it in here, injector flow 2.2 bar. It is actually on this, it's not really vacuum tracking. It does have a vacuum port on it in the factory configuration, but it's actually for idle, so it actually reduces fuel pressure during idle, but it doesn't connect to the manifold, so it doesn't pull like a lot of vacuum on it. It's just in the intake, so it's kind of a strange deal. It's not like your typical fully vacuum reference to the manifold tracking. Dead times, I just left these kind of similar, so somewhere around 14 volts. 1 millisecond dead time is usually pretty close on most fuel injectors. So just left that, and the rest of it is also just default for currently right now. You can actually figure out your injection angles and get those a little bit closer, especially with large injectors, but we won't worry about that right now. Startup and warm up. This stuff actually really got me when I first was tuning this. The defaults in here had way too much. They'll have like, at 68 degrees Fahrenheit, they had like 40% extra fuel, and it was barely able to run. So you kind of just have to mess with these. Honestly, it's something you have to go in and just adjust until the engine likes it. It really is just a case of the engine wanting what it wants. So basically, cranking fuel like left pretty similar to what it is from the factory, and then the warm-up fuel, I just took quite a bit of that out as well. It just seemed like when it had too much fuel, it was running really rough. But these, honestly, you can use the defaults and then just play around with it from there. Take out 10%, add 10%, see what the engine does when it's starting up. It's not really that big of a deal to change that. It won't hurt anything, especially on startup. All the additionals right here, I left as stock, or left as default. So overrun fuel cut is the only thing I think that I enabled, and this is also basically the default for MaxxECU. This is just nice, so when you're decelerating coming off the highway or something like that, it shuts off fuel, so you save a little bit of fuel there. And lambda control I don't have set up, but I will do that in a separate video. But pretty much everything else is just default. Acceleration enrichment and everything else as well is also default. And this is just a base. This is a base tune. This runs and drives great, but it is just to get you going until your setup is completely gone through. Motorsport, they have all kinds of different cool stuff you can do. We didn't do any of that yet. Speed control, nothing there. CAN bus, I did set up my lambda sensor on the CAN. Let me just pull that up for you just so you can see it. I'll go over this in another video, but basically my Bollinger AFR 500, all I did was set the CAN ID to 0x500 because that's the default for the Bollinger, and the biggest change was going from little endian that's default to big endian, and then my lambda value was correct. All right, so let's go down advanced. I don't have anything in there. Inputs, trigger and home input. This is a VR sensor. I've got some stuff pulled up here that we can see. Now that we've got this, we can close up a few things. But basically, the crank position sensor on these is a 36 minus 2. Let me pull it up here. There's actually some really good documentation that you guys might enjoy from Haltech on UZ engines, but they also have the same crank trigger as the VZ engines. So over here on the right is the 36 minus 2, so it has 36 teeth and there's missing 2. And they are also about 152 degrees, 153 degrees out from where the crank position sensor is. So we'll get to that more in the settings. Let's go check that out. So we're a VR sensor, zero crossing, falling on the trigger polarity. missing tooth. This is just the basic setup of the crank trigger. Missing tooth. We're not using home signal. This is before top dead center, 36 -2. And then I used a timing light, and mine was 155 degrees before top dead center to get it lined up at top dead center with 0 degrees of ignition advance when you lock the ignition table, like at 0 or 10 degrees. So this varies a few degrees depending on what your engine is. Like from the factory, they're all slightly different. You have to check it with a timing light. So don't worry about that too much. Sensors. This one is very specific. Let me pull up kind of how I found this. There's a documentation from DIY Auto-Tune. Thank you to those guys over there. They actually did a Tacoma 4Runner plug-and-play technical detail write-up. And in here, they show that the sensor calibrations for the intake air temperature sensor and the coolant temperature sensor, and their bias resistor settings that are in the factory ECU from Toyota. Now, I'll go over this in a separate video in a little more detail because it is very specific. But basically, if you're sharing a sensor with another ECU, you have to tell the MaxxECU to not use an internal pull-up resistor, which it has, but you have to use an external, and then you give it the external value. This is basically how the resistance is measured across a 5-volt signal. It has to split the voltage and then do a little bit of division on it, and that's what gives you your resistance. But it needs to know what the external pull-up resistor is that Toyota uses. So sometimes on vehicles it can be difficult to find that, and thankfully the DIY Auto-Tune guys had it, and so yeah, we're just going to use these values, and it works great. So the other thing is the throttle position sensor. The throttle position sensor, all I did was, if we go here to my table of my wiring, where's throttle position sensor? All we need right here is this voltage output. So on the stock Toyota 4-pin throttle position sensors, pin 3 is the voltage output. So you have 5 volts in, sensor ground. You have an idle switch, which just says whether or not the throttle position sensor is at idle. And then there's a constant variable voltage out. It's usually around 3.3 volts. And then it goes up or down from there. So that's what's connected on the MaxxECU, just that pin 3 on the connector in the engine bay, and that's where I got this voltage. It goes from 0.775 up to 3.39 when you floor it. I also did notice that there's a lot of voltage drop in this system, and this is better to do while the car is running. That way you're using the voltage while it's running, not the voltage while the vehicle's turned off. So all I did was just click this while it was idling, and then I clicked the current voltage just by foot brake flooring it for just a second, just enough to get a full throttle reading, and then clicking it. Lambda sensor. This just depends on what lambda sensor you have. I have an external CAN bus unit that I'll show in another video how it's set up. Everything else is just set up. I'm going to do launch control and show how to do that, so I just set that up for fun, but everything else on the inputs is pretty much good. Outputs really also don't have anything else. One thing that's really nice about piggybacking off the stock ECU is that the MaxxECU, we're not using all of its inputs and outputs. All we need is a few inputs and outputs from it, and then the rest are available because the factory ECU is doing a lot of the other input and outputs. So it saves you on that as well. Let's see what else. Let's get into the real deal here. Let's get into the tuning. So this is a base fuel map that I came up with just in a really short amount of time tuning. This will vary depending on where your altitude is, what fuel and everything you're running. But this is roughly what you get. This engine has peak torque at 3,800. So you'll see right here, right around 3,800 is where the highest amount of fuel in the VAE table is. That's usually where I always go to look for where peak torque is on an engine. If you set everything to the same air fuel ratio and then you tune it, it will show staying in that same brake specific fuel consumption where peak torque is. So anyway, it's just right here, and then you need a little bit less fuel after peak torque. But anyway, this is kind of variable. The default that MaxxECU gives you will run the car. It's not great. You can go in and make some global changes, add or subtract fuel just to get it going. In my previous videos I've shown, I usually just block out the idle area and then just change it 1 or 2 at a time until it idles right around stoic, or a little bit richer if it wants it. Lambda table. This one is also just super basic, like depending on what you're doing, if you're doing forced induction or if you're doing like really high performance, you're going to want more fuel than this, but for just driving around, getting a base tune, this is totally fine. 9.8 lambda, that's about 14.1 AFR, and then 9.2 lambda is like mid 13s. So this will get you pretty close to where you need to be. So up in your full throttle area, you're going to be mid 13, low 13s would be great. And then yeah, everywhere else, just cruising around and idling and stuff, you can shoot for about 14 to 1 right there. Ignition table. This one, basically I just use the default for the MaxxECU, and I just took out timing as I felt was appropriate. Originally I put up at the top here, it had like 27 degrees in it at full throttle, and I was getting a little bit of detonation. I could hear it knocking at full throttle, especially around peak torque, and so basically I just backed it off to like, it's getting like 23, 24 degrees max. So it's a lot happier. This is something really you can only know for sure on a dyno is making a difference. However, just with like pump fuel, you can hear it knocking. You just want to take some ignition out of it, and you know the difference in a few degrees while you're doing a base tune is not going to be significant. You just want to make sure it's safe. So even if you came in here and you just set this all to like 20 or 22, you'd probably be just fine. In my experience, it really just didn't like it when I was above 24 degrees total advance at full throttle on 91 octane. So this is pretty much everything on this tune. There's some really good resources, like I said, from DIY Autotune. They had the sensor calibrations that saved me a lot of time. It was very difficult to find that elsewhere on the internet. They also have some of the pinouts for the idle temperature sensor, Haltech as well, the air temperature sensor, sorry. They also have some really good stuff that is basically shared between a lot of Toyotas. So like between the 2UZ and the 5VZ, or the 2UZ and the 2UZ and 5VZ, sorry. Those ones, very similar. They have the same pinout. So basically I just went in there, grabbed the air temp signal and found where it was, verified it with my multimeter, and we just connected that to the MaxxECU, and we're good to go. So anyway, there's some good resources out there. Even if it's sometimes, if you don't have a lot of information on an engine like the 5VZ, there's not a lot of performance information. There's a lot of like documentation and factory service manuals and stuff that are really helpful, but sometimes you got to find stuff that's similar, and then you can go from there and find some really good stuff like the MAF sensor pinout and stuff. That was actually somewhat difficult to find for a 5VZ, but on the 1UZ or 2UZs, it's really easy, and they're actually the same. So all you do is use your volt ohm meter to make sure that you are correct before you wire anything up, but it just helps you get closer when you're searching for stuff that's very difficult to find. Same with like the spark plug order. There is one thing that I did remember that was like a little bit of a pitfall for me, is the outputs On the MaxxECU for ignition, they just run sequential. So like output 1, 2, and 3, they just go 1, 2, 3, 1, 2, 3, 1, 2, 3, and they're batch fired. So you can hook up the coils just like this. I mean, you have to, but you have to set the order of coils to 1, 2, 3. It can't be 1, 2, 3. Like Toyota will actually, they name their coils coil 1, coil 2, coil 3, and then they change it with their software on how it triggers them. But if you look at the firing order, it's 1, 2, 3, 4, 5, 6. So 1, 2, the second sequential coil that has to fire is coil 3, or this cylinder 5 back here. So it actually goes 1, 2, 3, 1, 2, 3. Anyway, if you're looking for a MaxxECU of your own, LPS Fab is a great resource. You can get pretty much any one of the MaxxECUs that they offer from them. They are a great, reliable source, and you can get it shipped in just a couple of days anywhere in the United States. They are great to work with, and there's some good documentation over on DIY AutoTune, Wikipedia, Haltech, LinkECU. They all have some good documentation. So anyway, I've got another bunch of videos on this series coming up, but I just wanted to show kind of transparently how to set this up, and hopefully someone else can make good use of this. There's a lot of people out there supercharging and turbocharging their 5VZs now. You know, the community, other than the superchargers that come factory, it's been a little bit slow to realize that these are a very good engine for power as well. They just make power down low, but for off-roading and truck kind of stuff, that's totally fine. So just trying to spread the word on how to get a good tune in your 5VZ. If you like this and you're interested in watching more, stay tuned and subscribe, because I got more videos coming, especially on the MaxxECU. So thanks again, and consider subscribing or becoming a channel member. Thank you.